everyone, welcome to my channel CSIR-NET Chemistry Facts. Today we will discuss the CSIR-NET's 2019 December Part C 4 marks question. And this question I will discuss in a very simple and conceptual way. Many students have feared attending the organic chemistry question in CSIR-NET examination due to the multiple factors to remember to answer a single question. But in this video, I will try to prove that the concept is the important thing, and by that you can solve the question. No need to remember a lot of things for a question to answer. So guys, how to give the answer in a conceptual way, I will discuss today. So guys, let's start to discussing of this question. You can see this question have two parts. So this is the first step and this is the second step. And this is a reactant. So this reactant will react with this condition, and this condition is actually matching with the Heck reaction condition. So we don't have to remember the name of this Heck reaction, but we have to know how these reagents will react in the reaction medium. And after this first step, the product will form, that product will go for the second step. And in the second step reaction, it will form the final product. And this is the structure the final product is given. Which will be the correct answer we have to determine. So guys, I will go for the one by one. So first I will come for the first step. So let us start. So guys, in the first step, this is the reactant and this is the reagent. And this reagent is actually the equivalent condition with the Heck reaction. But we don't have to remember the name of this Heck reaction, but we have to know this reagent, how it will participate in the reaction. So guys, you can see there is a Palladium Catalyst, and this is the structure of the Palladium Catalyst where the PPH3 are there, which are the neutral ligand, and these two Cl have the negative charge, right? And therefore this Palladium has a two positive charge. So this is a +2 oxidation state, and this will react with this reactant, and this carbon iodine bond is there, which is a much more polar bond, and this bond is easily breakable bond, and hence a addition will happen of palladium in this bond. So a addition reaction will take place in this case. Okay. So guys, what will form? It will form this one. And guys, you can see this L is actually representing this PPH3, okay? Since L is equal to PPH3. And this palladium is actually +2 in oxidation state. Now, styrene is given inside this. So, styrene is actually as a reactant it is given, right? So, it will react here and it will form a pi complex. So, guys, this will be the structure of the pi complex. So, this is the structure, okay? And you can see in this pi complex, this pi bonding electron is donated to the vacant d orbital of the metal, and hence this bond will be electron deficient, and therefore this carbon and this carbon both are electron deficient, and that will lead to a migratory insertion. And this bond will migrate. This bond can migrate here or here. So why it will migrate? It depends on the stability of the carbon ion producing after the migration. You can see if it will migrate here, then the carbon ion will form here. That carbon ion will stabilize via the resonance with this pH ring. But if it will attack here, then the negative charge will form here, and there is no such stabilization factor to stabilize this negative charge. And therefore it will selectively attack in this position, not to this position, okay? So therefore it will attack in this position. So what will happen in this case? So it will form a sigma complex, right? So guys, this will form, and you can see this is a sigma bond. So therefore this complex is known as the sigma complex. Okay, so this is the example of sigma complex, and here you can see the hydrogens are there, and this is the alpha position, and this is the beta position, and this is the beta hydrogens, and this bond will come like this, and this beta hydrogen will come to the palladium. So this step is known as the beta elimination, because here the beta hydrogen will eliminate and a double bond will form here. So guys, what will form? So this will form, and here this group will be intact like this. So this is the final product, and what will form this palladium? This palladium will form this one, and this Et3N base is given in this reaction medium, right? This Et3N, what it will do? This base will abstract this proton, and this will come like this, and this I minus will remove, and it will form this complex where the palladium will be in the zero oxidation state, and this will again go for oxidative addition with this compound, right? So this palladium, this will go for oxidative addition and it will form this one, and again it will be form this one. So there will be a cycle. Okay, so this will act as a catalyst, and this is the product whatever we will get in the first step. So this is the product for the first step, and now I will go for the second step with this product as a reactant. Okay, so guys, let us start the second step. In the second step, you can see this is the starting material what we will get as a product in the first step, and this is the reaction condition where we can see they given as a Graf second generation catalyst, and this is the structure of the Graf second generation catalyst where you can see this blue color part is the active part, and other ligands are actually there for stabilizing this complex. And what is the job of this Graf second generation catalyst? It will do the olefin metathesis. That means two olefin will join together to form a single olefin. Now, if you see in our starting material, there are two double bonds are present, and there is a benzene ring is present. In the benzene ring, three double bonds are there, but as they are in the aromatic situation, so they will not react. So now among these two, which one will react? If you see this one, this has a resonance with the benzene ring, and therefore the double bond character of this double bond is quite less. But this does not have any resonating structure with any other conjugated double bond, and therefore this have a 100% double bond character, and hence this will react with the Graf second generation catalyst. And how it will react? This is the ruthenium, and this is the Graf catalyst, and it will react in this fashion. This will react here and this will come here. So a four-membered ring will form. So guys, I will draw here the four-membered ring. So this bond will form and this bond will form. So you can see this is the four-membered ring. And after formation of this four-membered ring, what will happen? This bond will come here and this bond will come here. So therefore, a styrene molecule will come out and double bond ruthenium will form here. So guys, I am drawing the structure here. So the double bond ruthenium will form here and a styrene molecule will come out. Okay, and guys, you can see now this ruthenium is very close to this double bond, though this double bond has a less electron density, because actually the electron density moves towards the benzene ring, but this double bond will react now because of the close proximity. So a intramolecular ruthenium catalyst will react with this double bond. So guys, what will form? It will react like this. This will react here, and this double bond will open and it will react here. So a four-membered intermediate will form in this case. So it will form this one. So double bond O, and here we can see so this will form. So this four-membered intermediate will form, and now we can see this bond will come here and this bond will come here. So therefore we will get back the Graf second generation catalyst, and that's why it is a catalyst because it will come out after the reaction is over. So guys, now we'll see what will be the product structure. So this is the product structure. So this is the catalyst come out and this is the product structure, and here you can see this is a 1, 2, 3, 4, 5, 6, 7. So 7-membered ring was formed. So guys, this is our final product. Okay. So now let's see which option is showing this structure. So we'll come for the options now. So guys, this is the structure of the final product, and if you see this 4 option, you can see the phenyl groups are there in this 2 case, and there is no phenyl group present in the final structure, and hence this option number 2 and option number 3 is the wrong answer. And guys, if you see option number 1 and option number 4, then if you see the double bond position, then the double bond should be present adjacent to the benzene ring, and here we can see there is saturated carbon present between the double bond and the benzene ring, and hence this is not the correct answer. So this will represent the correct structure of the product, and hence option 1 is the correct answer. So hope guys you understand this mechanism. Thank you so much for watching this video. Please like, comment and subscribe this YouTube channel, and please share this channel with your friends. Thank you so much.